Hello everyone. In previous class we studied about unit and measurement. Today we will start a new concept that we mainly used in physics, that is mathematics for physics. This is very important for all your physics. The reason being, mathematics is also known as the language of physics. If you know the mathematics, so calculation or everything in the physics will be so easy for you. So next part is mathematics for physics, or you can say we will study here about mathematical tool. Mathematical tools means the instrument which we will use inside the physics. Clear? So that's why I told you this is very important, because without tool we cannot move, we cannot find out any calculation inside the physics. Clear? So in mathematical tool, first we will study basically any quantity are of two types. Either it is constant or variable. So a quantity is of two types. Either it is constant or variable. So a constant is one which remains constant throughout the expression or equation or any program, and a variable is one which may vary. So which may vary according to the requirement. Clear? Now this variable is again of two types. So variable is again of two types. One is known as dependent variable. And another one is known as independent variable. I'll explain one by one. So dependent variable are those which depends on the another quantity, another variable. Which depends on the another variable. Clear? And independent variables are those which are independent, or you can say which do not depend on any another variable. So which do not depend on the another variable. For example, time. Here, for example, speed. So speed depends on the distance and time. Okay. So this is known as the dependent and independent variable. So quantity can be classified as constant and variable. Again, variable are classified in two groups. One is known as dependent variable, another one is known as independent variable. Clear? So if one quantity depends on the another quantity, for example if we'll take y is equals to 2x, that means here we can if we want to calculate the value of y, it totally depends on the value of x that we will choose. So suppose if we will give a value of 1 here, this that we will provide it, the value of x that we will choose or we will provide it, according to this value, this y is equals to 2 into 1. In place of x, what we have now? 1. So put it over here. Now this becomes 2. So y is equals to 2 for the value of x is equals to 1. Clear? Next, if we will give x is equals to 2, what will happen? So y is equals to 2 into 2, that is equals to 4. So y is equals to 4. X is equals to minus 1. Then y is equals to 2 into minus 1. So y is equals to minus 2. So here you can see y depends on the value of x. So can we say in language, here we can say y depends on the value of, or value of y depends on the value of x, or y is dependent depend on x. That means here y is dependent variable. Y is dependent variable. And what about x? X is independent variable. So in mathematics we can say, or y is a function of x. Means according to the change in x, y will change. Or here we can say y is equals to function of x. This can also be written as y is equals to function of x. Clear? So now we can say this, here it is value of y is 2x. So now we can say y is equals to a function of x is equals to 2x. Clear? Because value of y depends on the value of x. That's why it is also known as function of x. Clear? So next part is function. Clear? So our next part is function. This function means this y equals to function of x. So this function may be either algebraic function, in first example what we have now, y is equals to ex. So this function is known as the algebraic function. Next, trigonometric function. Next, exponential function. Inverse function. logarithmic function, and many more. So, if we will take the example of one by one, so algebraic function, for example, y is equals to fx is equals to 2x. Clear? Trigonometric function, for example, y is equals to f of x is equals to sin x. Clear? So here this sin x is a trigonometric function, exponential function. So y is equals to fx e to the power x. Inverse function, for example, y is equals to sin inverse x. Clear? And logarithmic function, for example, y is equals to fx is equals to sin inverse x. Logarithmic function, for example, y is equals to fx is equals to log x. So we'll discuss one by one all the function. First we will start with trigonometric function. So next part is we will start with trigonometric function. Okay, so suppose we have a circular path here from this point, let this point is P and this point is Q. Clear? And we are moving in this way. Suppose this angle is theta. Clear? And the radius of this circle is r. Suppose the length of this arc is s. Clear? So here the angle theta is equals to arc length upon radius. Clear? Or you can say theta is equals to arc length, that is s upon r. Clear? Unit of angle is, we'll choose either a radian or degree. So radian, degree. Clear? Okay. Now how to convert, if any value is given in degree, so how to convert in radian? So around the point, the total angle, is 360 degree. Around the point O, the total angle is 360 degree. So here 360 degree is equals to 2 pi radian. Here is the relation between these two. 360 degree equals to 2 pi radian. Clear? Okay, so from here you can also calculate the perimeter. The question is what? The total angle is 360 degree. Okay, so angle is equals to arc length upon radius. So here we have total angle, that is 360 degree, can be also written as 2 pi arc length. The total length is known as the perimeter. So perimeter of, or you can say circumference of circle upon radius is r. Clear? Or simply you can put by this formula s by r. So remove this or put it over here s. Clear? Where s is the arc length. So here s can be written as 2 pi r. That is the perimeter of a circle. So from here you can calculate the perimeter of a circle. So now this 2 pi 360 degree can be written as 2 pi radian, or 1 degree is equals to 2 pi upon 360 degree radian, or which is equals to pi upon 180 degree radian, 1 degree, and this comes in conversion of degree to radian. Conversion of any angle from degree to radian. So 1 degree can be written as pi upon 180 degree radian. Pi upon 180. So suppose we have first example, we have d degree. Convert d degree into radian. So here we have d degree. So if 1 degree is equals to pi upon 180 radian, therefore d degree can be written as pi upon 180 into d radian. For example, we have to convert 90 degree into radian. Clear? So now this 90 degree can be written as pi upon 180 degree into 90. So 2, or you can say pi by 2 radian. Clear? 60 degree. So 60 degree can be written as 60 degree is equals to pi upon 180 into 60. So pi by 3 radian. Fourth, for example, 45 degree. So 45 degree is equals to pi by 180 into 45. 4 job. So pi by 4 radian. So with the help of this formula you can calculate any value in radian. Clear? Now next conversion is from radian to degree. Next is from conversion from radian to degree. Clear? For example, so radian. 2 pi radian it equals to 360 degree. Clear? So 1 radian can be written as 360 degree upon 2 pi. So this can also be written as 180 upon pi degree. Clear? So first example, if we have to convert arc radian, or take another example, T radian. So T radian can be written as 180 upon pi into T degree. Take an example. Suppose we have to convert 5 radian. So 5 radian can be written as 180 upon pi into 5. Clear? Or you can say not 5, we will take pi by 6 radian. Clear? In terms of pi. So pi by 6 radian. So 180 upon pi into pi by 6. So 6, 30, pi cancel. So this becomes 30 degree. Clear? Second, pi by 4 radian. So 180 upon pi into pi by 4. So 4, 45, pi cancel. So 45 degree. Clear? So here is the basic part, that how we convert from degree to radian and radian to degree. In next class we will discuss some more thing about the trigonometry, like values of trigonometry, caste system. Thank you.